The Leave Plan of Room specialist has found that, using our new 101 billion toy, it will be clear for eternity before that endeavor changes into a reality. On the remote possibility that it goes as coordinated, the trip to Proxima B will take nearly 20 years. So, sensibly, it will be a seriously extended period of time before we can expect to determine if there is certain life on that planet. The JWST has debated whether we are truly alone in this universe. Through the James Webb Telescope, it has discovered a few staggeringly humanesque things far away from Earth that bring us closer to the answer. Our mission to explore beyond has been uncontrolled throughout every human action. So much so that we have created countless media works and speculations concerning this matter. Our wonder about our place and significance in the universe has been unwavering. It is ingrained in us to constantly search for a companion. Despite how similar we may be, we could get legitimately closer to the answers we seek. But are they truly the answers we are looking for, or are they simply unsettling? Join us as we examine the most groundbreaking discoveries in the study of systems and planets on the journey to finding something we might not even be prepared to see. Lights far away. Experts have discovered what could be the most significant revelation in history. Back in 2021, when the James Webb Space Telescope was set to launch, an intriguing theoretical question was raised about the limits of our technology. The inquiry was whether, in the future, our telescopes would be capable of detecting artificial light on another planet, such as Proxima B, the nearest exoplanet to Earth. Proxima B, approximately 4.25 light-years away, was observed to be tidally locked, with a persistent day side and night side, much like our Moon. A speculative technological advancement for Proxima B could involve transferring power and energy from the day side to the night side using photovoltaic cells that generate electricity from starlight. In a paper co-authored by Manasvi Lingam, researchers demonstrated that an extensive network of solar panels on the day side of Proxima B could potentially be detected by future telescopes. Since the JWST was further developed, it allowed us to expand our search for artificial lights on exoplanets like Proxima B. Now, the fact that the James Webb Space Telescope did exactly that in 2024, using its higher sensitivity and advanced capabilities, suggests that the JWST might have found the artificial lights we were searching for. This discovery could potentially propel us into a new era of human progress. The universe of planets and exoplanets. To understand how this discovery was even possible, we must dive into the world of planets and exoplanets. Since the dawn of recorded history, humans have pondered the nature of the universe. Who are we? Where do we come from? Where are we going? These are age-old yet deeply complex questions that humanity has struggled to answer. With the rise of advanced technology, one might wonder whether we are any closer to finding answers. If you ask a philosopher, he might say we are still at level 0 in understanding ourselves in the universe. However, if you ask an astronomer the same question, you will see his excitement as he rushes to share the latest discoveries about the cosmos, made possible by cutting-edge instruments. These tools, often overlooked by the general public, are a testament to human progress. Today we have made the world instantly accessible. Now it's time to make the universe just as accessible. One of the most promising advancements in this endeavor has been made by astronomers and space scientists. Through their innovations, we have reached a critical point in technological development, one that has now enabled the detection of what might be artificial light on a planet light-years away. Indeed, we are talking about the James Webb Space Telescope. The James Webb Space Telescope. The JWST is a product of humanity's long-standing efforts to explore space and address some of the most fundamental questions. Are we alone? Who, or what, is out there? Where do we begin and where do we end? This infrared astronomy tool has already begun searching for answers to these mysteries. But first, you may be wondering, what exactly is Proxima B? Proxima Centauri B, or simply Proxima B, is sometimes referred to as Alpha Centauri CB. It is a super-Earth exoplanet that orbits an M-type star. Super-Earths may sound confusing, but don't worry, this text will clarify everything. Super-Earths are a class of planets more massive than Earth but lighter than ice giants like Neptune and Uranus. They are fascinating because they can be composed of gas, rock, or a combination of both. Their sizes range from about twice the size of Earth to several times its mass. Proxima B, in particular, is both a super-Earth and an exoplanet, meaning it orbits a star outside our solar system. The first potential evidence of an exoplanet was discovered in 1917. However, it did not generate significant interest at the time. It wasn't until 1992 that the first confirmed detection of an exoplanet left scientists astonished. Another exoplanet, first detected in 1988, was officially confirmed in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems, with 896 of those systems containing multiple planets. Understanding Proxima B and its host star. Proxima B orbits an M-type star, commonly known as a red dwarf. Red dwarfs are the smallest type of stars in the main sequence, making them incredibly difficult to detect. In the Milky Way, red dwarfs are by far the most common type of star. Due to their low brightness, astronomers have historically found them challenging to observe. The term M-type refers to the classification of red dwarfs based on their size and temperature. M-dwarfs, or M-type main sequence stars, have a maximum surface temperature of around 3000 K. As for Proxima B, its mass is estimated to be approximately 1.07 times that of Earth. Surprisingly, it completes an orbit around its star in just 11.2 days, compared to Earth's 365.25-day orbit. This rapid orbit hints at the small size of its host star, Proxima Centauri. The total luminosity of this star is only about 1.6% of the Sun's. In the visible light spectrum, its brightness is even lower, only 5 to 6% of the Sun's luminosity. More than 85% of its emitted energy is infrared radiation. Proxima B orbits its star at a distance of approximately 0.045 to 0.056 Australian dollars, astronomical units. Its discovery was officially announced in 2016. Why is Proxima B so important? With countless stars, planets, and galaxies in the universe, why is Proxima B of such particular interest to astronomers? There are a few key reasons. 1. Proxima B is the closest known exoplanet to our Sun, just 4.2 light-years away. While this is an immense distance by human standards, it is remarkably close on a cosmic scale. 2. It is part of the Alpha Centauri system, which is a triple star system. This system appears as one of the brightest celestial objects in the night sky, just behind Sirius and Canopus. 3. It may be habitable. Proxima B falls within its star's habitable zone, meaning conditions might allow for liquid water to exist. The potential for life on Proxima B is what makes it one of the most exciting targets for future space exploration. Scientists are eager to push the boundaries of our knowledge and investigate whether life, intelligent or otherwise, might exist on this nearby world. The search for life. The search for life beyond Earth has been a cornerstone of humanity's space exploration goals. In the past few decades, the discovery of exoplanets in the habitable zones of distant stars has spurred considerable excitement. However, Proxima B stands out due to its proximity and potential to support life. Astrobiologists and astronomers are particularly focused on the idea of life on Proxima B because of its location in the habitable zone of its star. The habitable zone is the region around a star where conditions might allow liquid water to exist on a planet's surface, crucial for life as we know it. Since Proxima B is in this zone, it could have the right conditions to support life, albeit under extreme circumstances. Researchers are investigating whether the planet's atmosphere, if it exists, might help maintain temperatures conducive to water and life. However, many challenges remain. For one, the intense radiation from Proxima Centauri, the star around which Proxima B orbits, could create harsh conditions on the planet's surface. Scientists are working to determine whether Proxima B could possess an atmosphere thick enough to shield any potential life forms from the radiation, much like Earth's atmosphere protects us from solar radiation. Technology and telescopes. The key to answering these questions, and unlocking the mysteries of Proxima B, lies in the power of modern telescopes like the James Webb Space Telescope, JWST. The JWST has already demonstrated its incredible potential in space exploration, providing detailed images and data from far beyond our solar system. The JWST's advanced infrared capabilities make it an ideal tool for observing distant planets like Proxima B. With its high resolution and sensitivity, it can detect faint signals from exoplanets, including potential artificial light sources, weather patterns, and even atmospheric compositions. By analyzing the data from JWST, astronomers are getting closer to determining the habitability of Proxima B and whether it could harbor life. One of the most exciting aspects of the JWST's capabilities is its ability to study the atmosphere of exoplanets. By observing how light from a star passes through the atmosphere of a planet, scientists can determine the composition of that atmosphere and look for potential signs of life, such as oxygen, methane, or other gases that might indicate biological processes. The future of space exploration. Looking forward, the quest to explore Proxima B and other exoplanets will only intensify. As our technology continues to improve, so too will our ability to detect and study distant worlds. Future missions, possibly using even more advanced telescopes or spacecraft, will build on the discoveries made by the JWST and expand our understanding of the universe. In the coming decades, humans may also send probes or even crewed missions to nearby exoplanets like Proxima B. While this seems like an ambitious goal, the rapid pace of technological advancement in space exploration makes it a more plausible prospect. If we do eventually travel to Proxima B, it would mark a monumental achievement in human history, a giant leap forward in our exploration of the cosmos. A new era of discovery. The discovery of Proxima B and the ongoing work of astronomers around the world represent the beginning of a new era in space exploration. Humanity is no longer confined to just observing the stars from afar. We are now actively seeking to answer some of the most profound questions about our place in the universe. As we continue to push the boundaries of science and technology, the possibilities seem endless. The exploration of Proxima B is just one chapter in what promises to be a long and exciting journey of discovery. The future holds incredible potential, and with each new revelation, we come closer to understanding whether we are truly alone in the universe. In the coming years, we may look back at these early missions and discoveries as the starting point for humanity's quest to become an interstellar species. For now, we can only wonder about the mysteries that await us in the vast expanse of space. The universe is out there, waiting to be explored. Where the James Webb Space Telescope comes in, the four essential goals of the JWST are to look for light from the first stars and frameworks that shaped the universe after the Big Explosion, center around the universe's progression and advancement, sort out star and planet development, and focus on planetary structures and the origins of life. As the JWST continues its appraisal of the set exoplanets, we draw nearer to the peak of these missions, from looking for exoplanets to searching for extraterrestrial life. So what exactly is SET? One could ask, taking into account that humans have always been an inquisitive species, examining and getting into literally everything that moves and doesn't move. It seems to make sense that a mission like this would appear on such a huge scale, envisioning that God has framed an inconceivably vast adventure. Regardless, with a touch of gold, we are blessed with being the ones looking for banners, more specifically electromagnetic mutters from human advancements beyond anything we could ever imagine. SETI, short for the Search for Extraterrestrial Intelligence, seems to be the world's most high-stakes game of find the stowaway, with our team as the searchers and the vast universe as the seemingly limitless hiding spot. It is one of those fields where scientists are like high-level Sherlocks, tuned into radio waves and scouring for that subtle "we are not alone" signal. This cosmic sleuthing started during the 1960s. Frank Drake, an eminent astrophysicist, was among the first to see radio transmissions from the stars. It was a striking moment. However, no alien appeared at his door, at least not yet. Searching for something this massive takes patience and can span a large number of years, sometimes much more. Very few definitive extraterrestrial signals have been found. However, despite these efforts, the excitement continues to grow as the James Webb Space Telescope continues to assess exoplanets like Proxima B. A whole field of hope is emerging. Will we inadvertently partner and find confirmed evidence of extraterrestrial life? Or will we just experience stunning signs right outside our ability to comprehend, giving us more questions than answers? The discovery of lights, in fact, could check the accompanying part of humankind's everlasting interest, where curiosity and progress merge into one immense, strengthening space story. So, let's keep looking, hoping to find confirmation that we are not truly alone. The discovery of lights from distant exoplanets, like those potentially seen on Proxima B, could be a huge push toward answering one of humankind's most important questions. Are we alone in the universe? As the Webb Space Telescope continues to explore the skies, its discoveries will undoubtedly spark more conversations, assessments, and perhaps challenges to our understanding of life, intelligence, and the nature of the universe. The implications of these revelations extend far beyond simple curiosity. They carry the potential to reshape our philosophical and scientific structures. For example, if we somehow end up confirming that Proxima B or another exoplanet harbors some form of life, it would force us to reconsider our position in the universe. Could life elsewhere develop in ways similar to ours, or would it present a completely new kind of existence? Would it follow similar evolutionary paths, or would it challenge everything we know about science and consciousness? Even if we fail to find direct evidence of intelligent life, the mere fact that we might detect artificial signals or lights from distant worlds would still have immense repercussions. It would suggest that intelligent human civilizations exist out there, potentially capable of altering their environments in ways that are detectable from our vantage point. This would confirm that intelligent life is not an anomaly but perhaps an inevitable result of certain conditions in the universe. However, it's essential to remain grounded and vigilant despite such revelations. While the potential for finding life is exciting, it also raises the question: what happens next? How should we respond to the confirmation of extraterrestrial life? Would we approach it with respect, curiosity, and scientific perseverance, or would the discovery spark a free-for-all, fear, or even political battles? History has shown that humanity's responses to new revelations, especially those that challenge deeply held beliefs, can be unpredictable. We should also consider the ethical aspects of our inquiry. If we indeed find confirmation of life, particularly intelligent life, what does it mean for our duty as stewards of our own planet? What moral considerations should guide our interactions with different forms of life, whether microbial or advanced? These are not questions that can be easily answered, and they will likely be a central part of the conversation as we venture further into the universe. By the way, the quest for life beyond Earth, driven by instruments like the James Webb Space Telescope, represents an extraordinary intersection of science, philosophy, and humanity's future. As we journey deeper into space and push the boundaries of exploration, the discoveries made by the James Webb Space Telescope and other advanced instruments open up entirely new domains of possibility. The search for exoplanets located in the habitable zone, where conditions could support life, has captured the imagination of astronomers. Proxima B, located so close to Earth in galactic terms, is one of the most promising candidates for further study. Its position within the habitable zone of its star increases the likelihood that liquid water could exist, an essential ingredient for life as we know it. Nevertheless, finding life, if it exists on Proxima B or elsewhere, will not signify the end of the story. The next challenge will be deciphering the data. Are we truly detecting artificial signals or signs of intelligent life? And regardless of whether life is confirmed, how will we handle the immense moral, social, and scientific challenges that come with this discovery? If there are other intelligent beings out there, how will we communicate with them? What will we say, and how can we ensure that our actions align with the responsibility that comes with such knowledge? These questions highlight the profound impact such discoveries could have on human civilization. The quest to understand life beyond Earth is not just about finding answers, it's about shaping the future of humanity in ways we can scarcely predict. Our continued exploration of the universe will not only expand our scientific knowledge but also deepen our understanding of what it means to be human. As we continue to push the boundaries of exploration, the discoveries we make will likely open new questions, new possibilities, and new responsibilities. Every step we take in uncovering the mysteries of the universe, whether finding signs of life on distant exoplanets or studying the fundamental nature of the cosmos, will require us to reflect on our place within this vast, awe-inspiring reality. One of the most profound aspects of the search for extraterrestrial life is its potential to challenge the very essence of what it means to be human. If we discover that we are not alone, it could redefine our understanding of life itself, how it originates, how it evolves, and what its future might hold across the universe. Would we begin to see ourselves not as isolated beings on a small planet, but as part of a much larger, interconnected cosmic community? This realization could shift our perspectives in ways we can hardly anticipate. It could open the door to new forms of cooperation, communication, and even collaboration with other intelligent civilizations if they exist. On the other hand, it's also possible that such discoveries could have less harmonious consequences. The reality of intelligent life beyond Earth might provoke fear or competition, with profound geopolitical and social consequences. How we, as a global society, handle this information, if it ever comes to light, will have a lasting impact on the future trajectory of human civilization. We will need to navigate these challenges with great care, ensuring that our responses are guided by wisdom, empathy, and a sense of shared responsibility for the future of our planet and any other life forms we may encounter. Moreover, the continued work of the James Webb Space Telescope and other advanced technologies promises to advance our knowledge of the universe in unexpected ways. Each new discovery could open up even more profound questions that require a blending of science, philosophy, ethics, and even spirituality. What happens when we find not just evidence of life but proof of intelligent life? How do we balance the excitement of discovery with the ethical complexities that accompany the knowledge of other civilizations? And what role do we, as humans, have in the grand cosmic story? As we venture further into the universe, we will be forced to confront our own limitations, not just in terms of technology, but in terms of our imagination, our ethics, and our understanding of what it means to be a part of this vast, ever-expanding cosmos. Ultimately, the quest for life beyond Earth is not just about answering the question of whether we are alone in the universe. It is about exploring what it means to be a conscious, curious, and evolving species in an ever-changing, boundless reality. Whether or not we find life on distant worlds, the very act of seeking answers will continue to shape the future of humanity, propelling us forward as we search for deeper truths about our existence and our place in the cosmos.